right, is it going?
Yeah, it's good.
All right. So we're going to look a little bit at section 3 of chapter 13, curved mirrors. So last lesson was on flat mirrors. What was the name for the image that we get to see in a flat mirror?
Virtual image.
Is that what you're going to say? Yeah. A virtual image. Because it looks like it's there, but it's not really there. You are the object, or whatever's in the mirror is an object. Now, things change a little bit when the mirrors get curved. So I've brought some curved mirrors.
Wait, so the mirrors that are plain, but like they act weird. Like those that are plain, but like you look like very small, very.
Well, they're not, plain means flat.
I mean, like yeah, they.
So they're not flat, but. So we'll start with the convex one. This one.
Well, they have these in like stores.
Yeah.
Wow.
So
That's
why use a mirror like this? What is it good for?
Because you a lot more area like it.
Wait, I want to take.
You can see
So-
more stuff.
So
like,
people.
outside of-
You should put like one up in your classroom so we can
Yeah.
like, see everyone. That'd be kind of
So
You'd see the kid in the back picking his nose.
So we'll put this in places like stores, or maybe on a blind corner where you're coming out on the driveway for a road, so you can see if there's a car coming. You may not be able to see exactly what car it is, whatever, but you can see that something's there. We'll put it in oftentimes on the right-hand side of our car. What does it often say in the mirror, rear mirror on the car?
Objects appear closer.
Look to your
They may be
surroundings or
closer than
something.
they appear.
Pay
Yeah.
attention to your surroundings.
There you go.
Okay, that one. They may be closer than they appear, or they look. It makes sense that the objects you see in here are smaller than they should be, right?
Mr. Sam.
Yeah.
We should take a picture with that mirror and put it as a group chat picture.
Okay, we can talk about that once we're
So,
done.
like,
I'll- Let me explain everything, and then you can take your pictures or whatever you want to do. Because as I demonstrate this, you may have more picture ideas.
Ooh.
Yeah. So this kind of mirror produces what kind of an image?
A convex virtual image.
Well, it is
Concave.
it's convex. Convex means it bulges out. That's convex, but what kind of an image? Is it real or virtual?
A real image.
It's virtual. It is like.
Oh wait, what?
It is.
Bro, there's a vocabulary word in here.
It is like a flat mirror. As far as the image is concerned, it's just smaller because of the way the rays go.
Yeah.
Now this one enters a whole other dimension of fun.
What is that?
Show us.
I will, but I'm going to come up kind of close and personal to you.
Oh, it's a
So
magnifying.
take a look at that.
It's a magnifying mirror.
Well, not to her. What do you see?
I see my big face.
Oh, here, this is a real image. This is a real image.
That's so funny.
That's real. That's real.
That's real. Yeah, that one's real.
It's like
You should-
amplifying it, right?
Drew, you being for real?
Yeah, no, it actually says it's.
Drew, you being for
Is
real?
it like
Yes,
amplifying
stop
it?
being funny.
Oh, you know those
What do you think?
those sunglasses stores? Where you like get to try them on. And
I
then
don't know
you
if
go
this
to
works
one.
in the camera,
Oh,
but
it's
you can see
Check your
things.
traffic works on camera.
Oh yeah, no, it's working.
Does
Like,
it
Why
work?
is it
You see
there-
the phone
why is it
really
there
big?
where I-
yeah, no, the phone's like really. Whoa, my face is in it now. No, the
can
phone
see
looks
my
like
bellow
small. I don't know. But...
Upside down.
Well, put your face over here. Is it showing you?
Oh yeah, my face is in it right now. I'm right here, but my face is in it.
All right. So you see yourself a little closer than you kind of are.
Oh, yeah.
comfortable with, right?
You see all
I
the
saw
pores.
Sydney.
Oh, that's so beautiful. Yeah.
What are you doing?
So
Oh my. Okay.
I always find it funny that we see ourselves so close. Go closer. That we almost are uncomfortable with seeing our own self that close.
I like it.
Alright, where's the gold mirror now?
What?
The gold mirror.
Ball?
The gold mirror?
I'm not sure what you're asking me.
Put something inside and it looks like it's there, but it's not.
Oh, yeah, I have that too. We'll
You
show
show
that.
that to us?
How many mirrors are you gonna show us?
Lots. Well, there's not that many. I mean, we've kind of covered all of them already, but there's a lot more to learn about them. So, what kind of image is this mirror giving you?
A real image.
Not yet, Drew. But I mean, yes. But hold that thought that it's going to be the right answer in just a second. What did you see when you looked into it?
Yourself.
Virtual. Now, the next thing I need to show you is
Wait, Drew, isn't the real one like the flip?
Why is everything upside
I'm
down?
just.
What you're saying?
It's just a vocab
How
word.
many mirrors do you have?
3. I mean, we have. What do you mean? How many actual mirrors or kinds of mirrors?
Like, how many mirrors do you have? Like mirrors.
I have these 2 big ones, and then we have lots of small ones. And you're gonna get to play with some of
Do you
them.
think you're?
Okay, I'll try to do this in front of the camera, and I'll move around a little bit. But what do you see here?
I can see. I can
it's
see
the
outside.
I don't know what I see.
Can you see
Is it like-
Gunzo?
I can see like the tree. I can see like the trees.
What the?
It's reflecting light.
Yeah, I see. No, that's
Oh.
The
weird.
closer you get to it, like
That's
depending
like
on how
that's like
close
a
you are,
that's like
it's
a
more
photo.
like-
Oh, that's how photos.
See, I can see.
That's true. That's how
It's
photos.
actually so cool. It's like literally projecting like the
Oh, I can
exact
see the
image.
prism thing.
That's how photos work. When you go in, it's like it twists the thing like the proper eye, and then you can I don't know. It's very weird.
We're gonna study the prisms thing. I'm pretty sure.
Yeah, the prism.
Yeah, how light is like.
Yeah, the same thing that happens in our eyes. You know.
All right. So, what were some of the things you noticed about that projection here on the?
Upside down.
It
It's
looks-
upside down.
It looks real. Like it actually like looks.
It is called a real image. There we go. That's
Yes.
Okay, so what is a real image?
It's an image that seems real.
It's
It's
an image
projected off the paper.
that can be projected onto a surface.
Yes.
Okay.
That is what we call a real image. Kind of confusing because you or whatever is the actual image, but we call that the object. What gets projected is a real image. Okay?
So us seeing ourselves is still a virtual. We're seeing a virtual image,
You're
but
seeing
then
virtual.
if
Yep.
we were project, okay, that makes sense.
So if you're looking at a mirror and you see yourself, that's virtual. If you can project it, it's real. You can't do both.
So I could put.
So that one is a real.
So this is real. Now what else do you notice about this image? I know you can't all see it, but what do you notice about it?
This
Upside
color.
down, what else?
It's foggy. It's like
It's blurry, right?
blurry, It's not.
It's blurry.
Is it 'cause
It's
the
not-
mirror's dirty?
It's not clear. And it's not because it's dirty. What?
Just because it's too far away, so it's not focused.
Kind of. There's actually another reason. And in your book, it talks about it on page 465. And we'll give it a try here. I'll try to draw it. If we were to draw a concave mirror this way, and then the rays, if this is the focal point of the mirror, a ray that comes here will bounce and go through the focal point.
Yeah.
But as we get further and further here, I forget which way it goes. I think it goes that way. Is that right?
Yeah, that
Yeah.
looks right.
It misses the focal point further and further. So the further we go from the center of the mirror, the less it wants to go to the focal point. So if I want an image, or a real image that's quite in focus, I really need to only use this part of the mirror. The further I go out on this mirror, the more out of focus I get. And so the image can be quite out of focus. And if you look, I'll show you again, that where is it the most in focus? And where is it the most out of focus? Is it towards the inside of this image or towards the outside of the image?
The inside is.
The inside, it looks like the very middle.
The middle
Like right there
is
is
much
like-
more in focus, right?
Yeah.
And the further we go out this way, the more it is out of focus.
I don't know why my brain just puts in focus like out of focus. Like it's.
So it's more out of focus here and more focus towards the center. Okay? Yeah. What do you guys need? Just. Okay. All right. Now, is there a way to get an image that's more in focus?
Yeah, you use a parabolic mirror.
That's the answer. A parabolic mirror Then all the rays will bounce, and you can see that in your book on page 465. They will bounce and come to a focus. Well, that actually goes two ways. We can bring all light into a focus, but we can also do the opposite. We could put a light bulb there, and then all the light coming from that light bulb will go out as a beam. Where could we use something like that?
Lighthouse.
A lighthouse.
Like a room. Could you light up a whole room?
Light up a whole room.
Wait,
Spotlights.
But
Okay,
spotlight is not how projectors. But how about car headlights?
I was gonna say.
Oh yeah.
Flashlights.
Yeah.
Anything where we want to project light in a particular direction, we could use a parabolic mirror. And car headlights are getting really focused. If you look at new cars, it's almost like the headlights are like, and they don't shine anywhere you don't want them to shine, like other people's eyes.
But that's
The-
actually good, right?
Yeah. There are some that are very annoying and I think should be against the law, that's another story, because they're halogen lights being one of those. They're so bright that I think they're dangerous for the oncoming drivers. But how about a telescope? Would you want a telescope made out of this spherical mirror, or would you want a parabolic mirror?
Parabolic mirror.
How come?
Because it's more focus.
We want more focus. We're trying to focus on very small spots in the sky. So designing a telescope, by the way, telescopes don't, you can only make a small telescope out of glass. To make a big telescope, you have to make it out of mirrors. Why? Because the glass is too thick and too heavy, and we'll learn more about that in the next chapter. But we can't make big telescopes out of glass. The one that helps us up in space and so forth, they're all made out of mirrors. Lots of reasons, but one of them is we can get nice focus and we don't have the refraction of glass. Glass messes things up, and we'll talk more about that. So that's the easy concept stuff. Let's talk about a little bit of the math stuff. On page 455, anybody here dyslexic or willing to admit it? This equation, I feel like is dyslexic. If you look at page 455, what is our equation? 1 over
P.
P plus 1 over
Q.
Q equals
1 over F.
F.
1 over F. Why do I say dyslexic?
Because P and Q can be changed.
I don't know about you, but I wish they had chosen different letters. But why does it kind of make sense to choose P and Q? We're talking about mirrors now.
Reflect.
A reflection, right? When you actually look in a mirror, it's reflecting the inverse, really, of what you are. Unless you go in the bathroom and then you get
Which
that.
is?
Yeah. So it's kind of showing you a flipped version of those letters. Now the math, my friends. The math on this is simple, but since it's all, what do you call it? Inverse? No. What do you call it when you put 1 over? Yeah, it's inverse, right? Yeah.
Reciprocal or
Not reciprocal, it's anyway, so our numbers are all on the bottom. You gotta watch your math. Okay, if you have trouble with the math, let me know. I'll be happy to help you. But what is the P supposed to represent?
Object distance.
The object distance. So if we're holding the mirror, what would be the P? Let's say it's 1 meter from my arm to the mirror.
1 meter.
It's 1 meter, that's my P. That's the object distance, okay? What is the Q? The distance to what? To the image. Now, if the image is behind here, then it's going to be a number behind here. But could the number be in front of the mirror?
What?
Wait, my head just
Yeah, what?
kaboom.
Could the image, let me get this right here. Could the image be in front of the mirror?
Oh yeah, if it's a
Oh yeah. Oh man, now I got to pay attention because I could have my object be in front of the mirror, and I could have the image in front of the mirror, or I could have the image.
Yeah, but aren't you?
Wait, how would the image be
Yeah,
behind
how
the
would
mirror?
image be behind the mirror?
Yeah, how would the image be behind the mirror? Yeah, but I'm just like in the mirror.
No,
Like,
he's in.
But it looks like you're.
oh,
back
you're
here.
saying so it'd be like just okay.
Yeah.
Can I see
So,
it? Okay.
a flat mirror, the image is always behind the mirror.
So like it would just be 0 then.
No, what
Oh,
you
this is
see
the-
looks like it's behind you.
So like the distance would be 0 then, because it's like in the mirror.
Uh,
Like the image distance.
no.
Wait, no, I don't understand.
I don't understand what you just said.
Okay. So when you guys are doing the flat mirror, you're doing a flat mirror. Let's say this is mirror, and you have your pin.
Because what you just used was not a flat mirror.
Right. But let's start with the flat mirror. Let's say this is a pin in front of the mirror. Where does it look like the pin is?
The other side.
It looks like it's clear over here, right?
Oh,
So this distance from here to here
it's the same.
would be your P. This distance is your
Would they be the same?
Well, in this case, yes.
But if you do
How would you
this,
calculate
do
that
this.
though? Like,
Will they always give us then like the cue?
But in the flat mirror, there is no equation like this. All right, because there's no focal point. There's no focal point. A curved mirror has a focal point. It turns out that if this is F, my drawing is not perfect for this. This is C. Andrew, can that phone see this? Yeah.
oh wait, sorry, I'm not good at this.
Do a little zoom in. I don't know that.
I know, I'm gonna zoom in.
So, in a spherical mirror, a spherical is a ball, right? It's made out of a circle. All right. So, if we were to continue this circle around, where would be the center of the circle? At C. Where is the focal point? Where would all the light come to a focus? It would come to focus at F. All right. So our equation is 1 over P plus 1 over
Q.
Q equals 1 over F. Let's say that F here is 1 meter. I'm just making up numbers. All right. If this is 1 meter. I'm going to put a 1 there.
So in this case, it's P and Q are not the same, right? Because
Yeah, that's better. Have,
Well,
go
it all
one more.
depends on
It's
where
more
we
that
put
one
the
back
image.
there.
okay.
It all depends on where we put the image. So let's go ahead and look at page. Look at page.
Yeah, it's
page.
better. I saw it.
Thank you. Look at page 458. 458.
Wow.
That is wild.
That is crazy. That looks like the things that we did yesterday.
I know.
What did we do yesterday?
You put a mirror and then you have to put a ruler and draw lines with the focal point. Yeah.
Okay, so I'm gonna back up and not call this a 1. We're just gonna draw it like this. Okay, so this is, I'm gonna look at number 2 on page 458. Number 2. So I want you to also look at the pattern of the lines. There's how many lines are drawn?
4. There's 4. Oh wait, what?
3 lines. You see them numbered?
Wait, I'm number 1.
Number 2.
Oh, number 2.
Number 2.
Oh yeah, there's 3 lines.
How many
Yeah,
lines are drawn?
3.
3. Notice they're numbered 1, 2, 3. Start learning this pattern. Look for the pattern that we're gonna observe here. So the first line, what do you notice about the first line?
It goes straight.
It goes straight and it hits the mirror. And then where does it go after that?
Goes through the focal point.
To the focal point. Okay? Done. That's line number 1. Where does line number 2 go?
Through the focal point, then bounces off the mirror.
Through the focal point, hits the mirror, and then does it go at an angle or does it go horizontal?
Straight.
Goes horizontal. Okay? And what is true about where those 2 lines cross?
That's the top of the other object.
That's the top of the other object. Okay, now I'm not measuring or being precise here, but I think I kind of got that close.
Yeah.
All right, so in this case, let's just ask the question, is this a real image or a virtual image?
That's a real image, right?
Is it behind the mirror
Oh, it's in
or is
front.
it in front of the mirror?
It's a real image.
So it's in front of the mirror, so it is a
Over here.
real image. We would have to project this on a screen or a piece of paper or something like that. Okay? So, let's say that our focal length, let's make it focal length of 2.
Oh, we're not drawing the third line.
I'll explain that in a second, but yes, you can. Let's see if I can make up some numbers here. Let's make this our P a 3. Let's make the math easier. 4. All right, how could I find Q?
What's the subject?
This is your chapter, man.
Let's go.
How do I find it?
Subtract 1 over 4.
Yeah.
So, exactly right. I would subtract 1 over 4. Oh, I forgot something. Go back to page 456. Second paragraph. You should underline this. Object and images distances have a what? Positive sign when measured from the center of the mirror to any point on the mirror's what side?
Front side.
Front side. So are these numbers positive or negative? Because they're both on the front side. Yes, Sydney?
Wait, what page did you just say?
This is 456, the second paragraph.
So we're going back.
I went back a few pages. I forgot to mention this.
And so can you say one more time? The object and the.
Yeah, you just read with me. The object and the image distances have a positive sign when they are,
From the center of the mirror
yeah, keep going to the end of the sentence.
to any point on the mirror's front side.
So if we're on the front side, those numbers are positive. So when will we get a negative number? When the image on the back side, then the image becomes negative. And it actually, the math all works, okay? So yes, back to this, we're gonna minus a quarter, and you get 1 over Q equals what? 1/4. So, does that tell you what Q is?
No.
Sort of. How would I get what Q equals here? Now it's kind of nice that there's ones on top, so you know Q must equal 4. So what is the distance from, you know what, that's not possible.
Now, how do we determine?
I created, that doesn't match my drawing.
Wait, because how did you even get 1/4?
Yeah, couldn't you just skip and just say it's 4? Because
I should have said it's 5 or something, and I'll show you why. Should have thought of this. But,
How did you even get 1/4?
okay, so first of all, I made it the problem, this is a 2, right? So this is a 2. What would C be?
What? Oh, that's the invert object, so that'd be the image distance should be 4.
If F is 2, C is 4. Okay, so not paying attention here, I randomly chose 4, which means my object should have been
Right there.
right there.
Yeah.
But it wasn't, not my drawing. So I should have chosen a number bigger than 4, which we can do in just a second. But the math on this is which of those pictures, which picture on 458
3?
is the math here for?
3?
It is number 3. The object and the image are at the same place. All right? Yeah. So, since I messed that up, you guys help me fix it. How could I choose numbers that will work for this drawing?
6 for the object.
Okay. So we'll go 1 over 6 plus 1 over Q equals 1 over? Huh? 2. Okay. So how do I do the math for that?
Subtract the 1/6 of
I'm
it.
going to subtract 1/6. So we get 1 over Q equals,
2 over 1/3.
1/4.
let's see, well that would be
It would be 2 over 6, which would be
3 over 6 minus 1 over 6. What would that get us?
1/3.
2.
1/3, right?
That's not bad.
So what does Q equal?
3.
So would that be reasonable roughly for my drawing? To be the image at 3? I mean, a little off on my drawing, but basically right? Okay. So, if you look on page 458, how many lines are drawn for each scenario? 1, 2, 3 lines. 3 lines. How many lines do you have to draw to find where the points cross?
2.
2. So you ask, well, why didn't you draw line 3? Well, because I'm lazy. And how many lines does it take?
2.
2. But I could draw 3, or I could draw any 2 of the 3.
Well, 3.
What's the third line that they give us that we
It
can draw?
shoots through the center and comes right there.
Okay, we go through the center of curvature, and we come right back. Now, my drawing is off, so it's not going to work because I didn't measure it.
Nobody
This
does.
should have been over here, right?
Because
So my drawing's off a little bit, but that is the concept, okay? Yes, ma'am.
So if you're drawing if you're ever drawing the reflection of an image, the first line would always go horizontal.
Correct.
Then go back through the focal point, and then 2 would go through the focal point and then bounce off horizontal, and then wherever that intersects would be where your image is at.
That's correct. And if you can just remember to do that, this chapter, next chapter are going to be really easy.
You can just always draw that.
Is
Then
there-
you'd always want to draw
So are we
something.
gonna be drawing
Yes.
all these? So you have to draw them to be able to do them?
No, not to be able to do them. I'm expecting you to be able to draw them and to be able to calculate them. So kind of like we did some stuff before where I'm going to ask you, please draw this drawing. And over here I'm going to ask you, please calculate it. Could you use a drawing sometimes to help you calculate it? Sure, but you don't have to. Yes, Andrew.
Can you explain focal point better, or the focal length or whatever? Because I don't understand how do you determine what that is?
Okay, just a second, Q. So the focal point is where if I had, this is picture number 1. So I get my rays coming from far away, maybe the dorm, maybe the sun, okay? And all these parallel rays come in, and where are they gonna go meet? At the focal point.
That's
That
where
is
it all intersect.
where everything intersects, that's the focal point. Or we could do the opposite. I could put a source of, like a light bulb right here, and as the light goes out, it would all then come out what?
It's all coming from that
Parallel.
one point, so that makes it.
Yeah, but
Wait,
I don't understand how I could if I just looked at a mirror that thing how could I
Well,
determine where the
it's
focal
not-
point is?
You can't just look at it and tell. You would actually take it out to some light, and we're gonna do it in lab. You're gonna take a mirror and you're gonna find out what the focal point is.
that next lab?
True, it'll have a point.
It is the next
It'll
lab.
all come together.
Yep.
In the middle of it.
Now, it also turns out mathematically that whatever the focal point is, C, the center of that circle of the mirror, is double the focal point
In any situation.
in any situation. And the other thing that I mentioned as a disclaimer is that the farther we get out towards the edge of the sphere, the less the rays want to come to that focal point. What is the word that means it doesn't do that, or we have that problem? It's called spherical
Aberration.
aberration. Spherical aberration. And that was on page 465. Spherical aberration. And it causes problems for us that we have to accommodate. Now, with a concave mirror, we can have both a real image, or if we get close enough, we can get a virtual image. How close do we have to get a virtual image? Look at your drawings.
Oh, page.
Page 458.
6, if you really close.
Number 6. So, tell me, if I were to choose a spot, where do I have to be to get a virtual image? I'm gonna go this way, I'm gonna start going this way, you tell me when to stop and I got a virtual image.
Right there,
Yeah, anywhere past
the focal
the
point.
focal point and I have a virtual image. Alright? So when I held it close enough to you that you could see yourself, that was a virtual image and you were inside the focal point. Alright, there's one more to mention. That's the mirror we started with on page 461. Can we draw the lines for that guy? For the convex. I didn't really make a big deal of it, but what does convex mean?
It's out.
Bulges out. What is concave?
It bulges in.
Bulges in. So that'd be that way. So can we draw the lines 1, 2, and 3 for this mirror?
Yes.
Yes, we can. It gets a little more tricky because where's the focal point of this mirror?
Right.
Oh, yes,
It's behind. So what would make that? Would that make it positive or negative? Negative. All right. So it's not too hard. It's a little bit to get it all into our heads and get it all organized, and then do that funny algebra with 1 over the fractions all the time. I just let you know, be careful, especially how you enter it in the calculator. And then even in our solutions guide, they do some interesting math on how to do it. There's lots of different ways to do it algebraically, but just pay attention to that. So, what do I want you to do for tomorrow? You can stop that now because we're done teaching, but